One is problem 1.16. It says a spot weld which holds the bracket to the plate at point A, as shown in the figure, can withstand a maximum twist in the plane of the plate of 100 Newton meter. Determine the maximum load W. So basically we have to find out how much this W is, so that in the plane of this plate the maximum moment is 100 Newton meter. So for this purpose we'll try to draw the free body diagram. In the free body diagram there will be, let's say, a reaction force here. We do not know the direction, so let's keep it generic in all directions. Similarly, this moment reaction will be M here. We don't know the direction of moment reaction also, so let's keep it generic. It will have all three components. Now when you draw the free body diagram and try to do the moment balance, let's keep an axis system here. This one is X, this is Y, and this one is Z. So now in this problem it will be better if you do the moment balance for the bracket. Now there will be two moments. One will be this moment reaction, that is at point A, this one right here, and there will be this other moment that is because of this W force, and both of these together will be equals to 0. Now when we look at MW, we'll try to use that formula which is R cross F, and we are doing this whole moment balance about point A in the system. So when you do the moment balance about A and look at the bracket from the top, the bracket looks like this, and this angle right here is 75 degrees, this is 125, and this one is 100. Now from the coordinate perspective, this is your x-axis and this is your z-axis. So about point A, the location of force W, if you write down your R vector, in the x direction we are moving. When we go from point A to point where the force is applied, in the x direction we are moving only this distance, but when you look at the from the top, this is the component that we are moving in the x direction. So this is 100 sine 75 degrees I cap. Now in the j cap we are not moving vertically at all, so there is no j cap component. And in the k direction, when we start from this point, we move 125 and then we move this, and this is going to be 175. So 125 plus 100 cos 75 degrees, and this is going to be in the k cap direction with the negative sign, because z is going down but we are moving upwards. Now in terms of force, there is that W force which is acting downwards, meaning minus W, and Y is up, W is down, so minus WJ. So if you calculate MW here, MW is going to be 100 sine 75 I cap plus 125 plus 100 cos 75 degrees. This is k cap, and this whole thing is going to be crossed with minus W j cap. Now remember, we have to figure out how much is the twisting in the plane of the plate. So if you look at the plane of this plate here, this plane will be defined with the normal going in the x direction. So basically we have to look at the x component of this moment. So when you do the cross product here, one cross product will be happening with I and j. This is going to give you a component in the k cap direction, but this k cap and j cap, when you cross k with j, this is going to give you a moment in the I direction. So the I component of MW is going to be 125 plus 100 cos 75 degrees times W, and this is going to be in Newton millimeters, okay, because lengths are in millimeters and force is in newtons. Now this has to be equated with the maximum limit that's coming from MA. At the moment I am not considering the signs because we are talking in terms of the absolute values. So this has to be equated with 100 Newton meter. So Newton can cancel out, and this millimeter and meter, this will give us another 1000 on the right hand side. This calculation here is going to be 158.9 millimeters, and so if you do this calculation, your W comes out to be 662.8 newtons, and that's the final answer for this problem.